Now let's talk about the structures made by differential stress. First, we're going to look at what happens in the lithosphere. Remember, the lithosphere is brittle. So brittle behavior is going to lead to fracturing, and fracturing leads to faults. So here is a stack of sedimentary rocks in the lithosphere. The blue is the youngest, the green is the oldest. When there's a fault, there is obviously a line, and these lines can be perpendicular or up and down, if you will. They can also be side to side. So we're going to look at the up and down, or the dip slip faults first. So when a fault appears and the rock breaks, movement along a dip can either go down or it can go up. Now, in order to understand and have reference about which side's moving up and which side's moving down, we refer to the footwall as the part that's below the fault trace, and the hanging wall is the part that's above the fault trace. So we refer to the hanging wall, turn it this way, the hanging wall moving down relative to the footwall. That's a normal fault, and I always remembered that because the hanging wall goes down the sliding board, if you will, the normal way. And then there's the opposite, where it moves up relative to the footwall. So that would be reverse faults, because they're going up the sliding board the wrong way. Now, the question is, which stress leads to normal and reverse faults? So, to do that, it's best if we determine which direction is getting longer and which direction is getting shorter. Remember, in compression, we have elongation perpendicular to the direction of maximum stress, and tension, we have elongation parallel to the direction of the maximum stress. So, best way to manage this problem is to measure. So, if the hanging wall moves down relative to the footwall, then we'll be able to see how far it moves apart. So here I'm going to put this side over here at 13 inches, and this side goes to almost 9.5, if you can see that. So if we have the hanging wall move down relative to the footwall, put this one at 13, you notice this is over here at 8.25 inches. So we went from 9.25 to 8.25. So did it get shorter or longer from left to right? If you said longer, you're right, which means it should be tension. So in order for a normal fault to develop, there has to be tension in the crust, and when it breaks and pulls apart, then this side will slide down relative to this side. In a reverse fault, we go the opposite way. So in this case, the hanging wall would move up relative to the footwall. If we put this side over here at 13 again, notice that we're down here to 9 inches. We were at 9.25, now we're at 9 inches. So again, here's 13, well, 9.5. To reverse fault, we lose a 1/2 inch there. Go back to normal fault. If we have the hanging wall move down relative to the footwall, get all the way over here, just about 8 inches, so we have lengthening versus shortening. Now, it doesn't matter actually which one moves up. We only say relative. So we could have a normal fault where this side moves up, but it's still, in appearance, the hanging wall is moving down relative to the footwall, and that's all we need. We just talk about relative motion. So those are dip slip faults.